Hello. In this lesson, we're going to talk about one-to-one function. Okay, so I'm going to put that title just a little later. But before we do that, we're going to recap, right? We started out with the definition of function. Okay, the definitional function. And we know that a function is a rule that assigns to each element x in a set of A, right? Each element x in a set of A, exactly one element called f of x in a set of B, okay? Exactly one. So we talk about that definition and we drew this diagram and we studied all of these functions last week. Okay, we studied all of these functions already. How many have we studied? 1, 2, 3, 4, 5, 6, 7, 8. So now if we reflect on the definitional function, we could actually, first of all, we can tweak the definition a little bit. So let's try to tweak the function a little, the definitional function a little bit, okay? Because we really want to understand this definition of function and be able to speak the word, speak the language itself. Okay, so I propose we're gonna tweak a little bit. So because we have dealt with domain and range, so I'm going to tweak the function such that it will be fitting and reflecting on what we have studied about function. A function is a rule, okay, that assigns to each element. Okay, so instead of saying each element, I'm going to give it a special name, input in a set of A. I'm going to change it to domain. All right, exactly one element. Okay, so we're going to definitely keep the exactly one. Exactly one is extremely important. But exactly one also meant unique. Unique. Okay, exactly one means unique, right? Exactly one means not less than one, not more than one, exactly one. That's what exactly one means. Exactly one also means unique. So I'm going to box this number, these two words. I'm going to, you can change it to unique if you like. Very important, okay? A unique element, okay? So exactly one. So I spend time here because I want you to pay attention to these. Okay, exactly one. Exactly one element, right? So we have learned about output, right? So I'm going to replace element by output. Exactly one output called f of x, right? We can remove the called, right? In the set of B, can we replace this phrase by another word? Yes, in the range. Because now we have realized that every rule, okay, that's fitting this definition, it has a domain, which the rule can apply to, the collection of all the numbers that the rule can apply to, so that exactly one output is produced for each input. If you think about that perspective, right? If you think about that perspective, that's exactly we have seen when we study all of these 8 functions last week. So A, I'm going to replace it by domain, and B, I'm going to replace it by range. Okay, so now we have tweaked the definitional function without changing the initials, but we use the words that we're more, we're going to use more frequently, right? So each element X in the set of A, we're going to call the set of A domain. And each element in this way, we instead of using element for element, input out in domain and range, we're going to just use a slightly different word, input, output. But for each input, the output has to be exactly one, which it has to be unique. Okay, we must understand that. This word unique, or exactly one, is essential. Essential in the definitional function. And of course, we have studied all of these functions, right? And they all satisfy that condition. And now, if we summarize, if we put all of these, what we have done about the 8 functions, then we notice that all of these functions, they're merely different rules. Okay, from what we have studied, if I replace the rule, okay, by a sequence of different rules, rule number 1, rule number 2, rule number 3, and so on and so forth, you can see different rules have, for different rules, we have different domains. For different rules, we have different range, and different rules corresponds to different pictures, right? So let's recall. If the rule is a constant, then we just have a horizontal line. If the rule is such, that's what we got, right? So you might notice that I have rearranged the functions a little bit. I've rearranged them a little bit. And I want you to think about why I rearrange them in these ways. Okay, think about it. Okay, you don't have to answer that question now. Okay, we're going to come back to this question. So next, we're going to introduce the definition of one-to-one function. Okay, so we're going to study these 8 functions. We're going to see which one is one-to-one and which one is not, right? So I'm going to put the title on the very top. Okay, this lesson is about one-to-one functions, but we haven't introduced the definition of one-to-one function yet, right? So now we're going to introduce the definition of function. So please get your notebook ready, paper, pencil, and I'm going to type it word for word. It's a very important definition, very important definition. We're going to use these definitions. Okay, so all of these definitions we introduce, we're going to use them throughout the semester. And that's not the end of it. You're going to use them in calculus. Okay, the very concept of function, okay, is going to be used from the beginning of calculus classes to the end of all of your calculus classes. That's how important this concept is. Okay, you may have multivariable, single variable calculus, functions, but you deal with functions. Okay, so you may have implicit functions, you may have explicit functions, but no matter what function you deal with functions, period. Okay, so the way I show you how to work these definitions is a demonstration to you as how you should study when you are taking math class right now. And also this is the way that I highly recommend as how you study when you are actually make it into calculus class. And that's how this method, excuse me, could carry you through calculus class successfully. Okay, so this is the way to study. This is the way to study. Okay, so one-to-one function. Okay, ready? All right. A function with a domain, okay, D is called a one-to-one function if, right? If no two elements, remember we have changed elements, right? To no two inputs of D have the same outputs. There are many different versions of this definition. Okay, many different versions, but they're all about the same thing. It's about input output. Okay, and there's a mathematical version of it. What is the mathematical version of it? Okay, you can see it says that is, right? That is to explain what it really means. What it really means. No two inputs of D. Okay, so you choose two inputs from the domain. Have the same outputs. But what is a mathematical explanation of that? Of course, when you choose two inputs from the domain, you're not going to choose the same one, right? You're not going to choose the same. Otherwise, we call one, not two, right? So that is, so the explanation, the mathematical language says, we know the input, right? So so this is based on, first of all, it's based on function, right? So before we talk about one-to-one function, it has to be a function first. It has to be a function first, all right? Now, for function, we got this. We got this, right? So for each input, there's exactly one output. So now, okay, with that context, right, we're going to explain what it means for this function to be one-to-one. That is, what is the if, right? That is, for each input, f of sub x1, right? Because for no two inputs, so we have two inputs here, and there's another, inputs produces an output, x sub 2. Okay, so what it means is that you pick arbitrarily, okay, for any that you have x sub 1 as input, and we apply the rule, so the output is going to be f of sub x1. For another input, x sub 2, it produces f of x sub 2. So for input 1, x1, we get output f of x1. For input x2, we get f of x2. So that's what it means. That is, these two will not be the same whenever What does it mean whenever? Always, always, right? Whenever your inputs are different, your outputs are different too. The respective outputs are different too, okay? So whenever x sub 1, whenever the input 1 is not the same as x sub 2. Okay, so this is the definition of one-to-one function. And what it means is that anytime your inputs are different, the outputs are different. And that's what is expected of a one-to-one function. So if you're told it's a one-to-one function, then you know that you can expect these to be true. You can expect these to be true. Okay, so whenever is a very important word. Whenever is a very important word. Okay, and in calculus classes, you also need to think about, well, so we're going to start from this class. What is the opposite of whenever, right? What's the opposite of always true? Right? What is the opposite of always true? And that goes back to what we talked about earlier in the previous lectures. Mathematical truth. If it's true, it's always true. False once, false, right? So the opposite of always is what? What's the opposite of always? Well, there's one case that it's not, right? There's one case it's not, or more, right? But we don't need more, we just need one. False once, false. So we must get that logic, So we have introduced a definition of, function, right? One-to-one function, both concepts are introduced. Let's observe these 8 functions we just studied to decide which one is one-to-one and which one is not one-to-one. Okay, so now let's start with the first one. So we're going to take all of it. We're going to take the 8. We're going to take all of it, right? We're going to study. Okay? And see, in our previous example, we chose c equals to 2. Now let's use 2. Okay? Now, with this function, right? With this function, we know it's a function for sure. It's a function for sure, right? We have studied that. But is it one-to-one? That's another question. Right? So in order to decide whether it is one-to-one, we're going to use a definition. We're going to decide, is this true? Because whenever, if this is true, then it is. If it's not, it is not. Right? It's that simple. This is the criteria. So I'm going to bring this definition over here. Okay, what do you think? You may like to pause the video right now to think about, is this true? Well, remember how we did the table? How we plot those points? Right? When we plotted those points, we noticed something, right? For each input, the output are exactly the same too. So for different input, they're not going to be the outputs are the same, right? So that's exactly what this function says. Therefore, we probably have realized, no, this cannot be a one-to-one function. You're right. Okay, you have that intuition. Very good. If you haven't realized that, it's not a big deal. Okay, so you just have to say, okay, what if it is true? And what if it's not true? Right? What's the opposite of whenever? Well, you just have to pick up that false ones, right? So this may not be true. If this is not true, the question is how do we phrase it? How do we phrase it? How do we say it? Okay. Sometimes we have students, they come to me, they say, I understand it, but I don't know how to say it. Okay, so I'm going to show you how to say it right to the point, right to the point. So that's part of the learning which you're going through, which I have gone through before as a student. You believe I was a student many years ago, right? I'm just simply older than you. And so I learned this thing before you. But math never changes. Okay, the mathematical truths will never change. That's good news, right? So what I have learned before, I can share with you. All right, so obviously it violates this statement, right? So how do you make it? How do you make your case, right? How do you make case? So I'm gonna say the opposite of it, okay? Because I only need one case, right? That says it violates the definition. So I'm going to speak that one case well, okay? So I'm going to say for, okay, x sub 1 equals to -1, x sub 2 equals to 5, right? These two inputs are not the same. So I pointed out these two inputs are not the same. But even though the inputs are not the same, but their outputs, right? F of x1 is equals to 2. That's the definition, right? That's the definition of the function. F of x2, f of x sub x2 is also equals to 2, i.e. f of x1 is the same of f of x2. So we have a pair of inputs. Obviously, they're from the domain. The domain is all real numbers. Even though the inputs are not the same, but the outputs are the same. And that violates the definition, right? The definition says, well, whenever the inputs are not the same, the output must be the same. Okay. So when you make your statement, when you make your case, you want to cite the definition. Okay. So we cited the definition. You see, in the way I'm writing it, I have cited the definition, but it violates the definition. It violates the definition. So I have one case that violates the definition, and false ones, false. Since this is not true, therefore we can say this function is not a one-to-one function. So now you can say thus, right? This function in our consideration is not a one-to-one function. Okay. At this point, I want to bring back another geometrical observation about function and its one-to-one function. Okay. Some of you might have learned that to decide whether it is a function, you use something called vertical line test. Vertical line test, yes. But what is a vertical line test? What is a vertical line test, right? Vertical line test says, if you have a graph of a function, okay? If you have a graph of a function, okay? And you draw vertical lines arbitrarily, freely. Okay, you draw vertical lines arbitrarily. You can draw any way you want, vertical lines. Each line, each vertical line touches the curve you drew, right? The graph, touches the graph, no more than once. This is a vertical line test. This is the vertical line test. What does it say? What does it say? Right? It says, well, for example, for this picture, right? It certainly passes a vertical line test. It passes a vertical line test. I'm going to draw vertical lines arbitrarily. But every one of them must be vertical line. Each vertical line, okay, so let's look at any particular vertical line. Each vertical line, if it touches the graph, right? For example, it touches the graph right here, right? At this point of touching, it tells us what? What does it tell us? It tells us that there's an input. Okay, so this is the input. Oops, sorry. Okay, that point of intersection, it shows us the input, which is the green. Can you see the green? Let me make it thicker. Okay, the input and the output. And the output, if it touches no more than once, that means the maximum it touches once. That means what? The output is unique. The output is unique, right? Let's look at another case, right? So input, so on this point of touching, sorry, so it's off a little bit, right? On this point of touching, okay, just this point, okay? And what's the input? This is the input. And what is the output? The output is unique because it touches no more than once. The no more than once actually include, doesn't touch it at all. Okay, because it could touch it 0 times, right? Touches 0 times is okay, but it cannot touch more than once. So this actually is in agreement with the definitional function. Remember, I emphasize exactly one, unique. So vertical line addresses the definition of function. Okay, so we know that a constant function is a function. You can also use a vertical line test. But what is one-to-one function? Do we have a such test for one-to-one function? Okay, yes, we do. Yes, we do. Okay, it's called a horizontal line test. Horizontal line test, okay? So vertical line test. Vertical line test is to test whether it is a function, okay? To test if a graph is a function. You can see how it is related to the definitional function. Okay, so I'm going to bring the definitional function along with us. So vertical line test is just another version of it. It's just another version of saying it is a function or it is not, right? If any graph that doesn't pass the vertical line test, it is not a function. So next, do we have a test? Do we have such a test for one-to-one function? Yes, we do. Yes, we do. It's called horizontal line test. Why horizontal line test? Horizontal line test. What does horizontal line test do? Right? What does horizontal line test do? Suppose I draw a horizontal line, right? Suppose I draw a horizontal line. Okay, so let me move it up a little bit. Okay, suppose I draw a horizontal line. So if you have a graph, right? So still the same situation, but this time instead of drawing horizontal line, a vertical line arbitrarily, we're going to draw horizontal line arbitrarily. Horizontal line, horizontal lines arbitrarily. Okay, you see the difference, right? To test if it's a function, we use vertical lines. To test if whether it's a one-to-one function, we use horizontal line test. Horizontal line test. Okay, when we draw a horizontal line, our horizontal lines arbitrarily, right? So I'm going to make another graph. Okay, the first one, we drew vertical line. Let me use different color, right? Vertical line. Vertical line, right? That's for the vertical line test. For horizontal line test, what do we do is we're going to draw horizontally, of course, right? We draw arbitrarily. Arbitrarily, including this one that overlaps with the function horizontally. You can draw any way you want, any density, right? Draw as many as you want. Okay. Each instead of vertical line, we change it. Each horizontal line. Okay, it's a basic copy and paste. I'm just going to do copy and paste. Each horizontal line touches the graph no more than once. What does that mean? What does that mean? Right? That's what's important, right? Does it really agree with our definition of one-to-one function? Now, so look at this, right? Look at this green graph. Most of the green graphs actually, you know, they don't touch it. They touch in no time, right? No touching. So for those no touching, we don't have to worry about it, right? But there's one that touches. So I remove the rest of them. I just leave the one that touches. What happens? What it means that it touches and how many times it touches. They overlap. They touch it infinite number of times. But what does it mean when they touch it infinite number of times? What does it mean when it touches it infinite number of times? Right? You see the graph of the function overlap with the horizontal line, green. It means that for this input and the other, for this point and the other point, they each have an input. Okay, these 2 points, they each have an input. This is the input. Better use something thicker, right? You can hardly see. Okay, so this input and the other input and the other input, right? And their outputs are identical. So when you draw the horizontal line, okay, so you saw that different inputs produces identical outputs. That violates the definition of what? Of one-to-one function. That violates the definition of one-to-one function. So now, can you still tell me what is the definition of one-to-one function? What is the definition of one-to-one function? Absolutely important, absolutely important. So right now, I want you guys to write down the definition of one-to-one function and also reflect on the words, on the graph. Okay. So the definition of one-to-one function, which I'm going to put it over here. Let's see. I'm going to move it around to see if I don't make a mess. Okay. So whenever, right? Whenever. So the definition of one-to-one function. This is the definition of one-to-one function. In our case, right? We have the horizontal line touches the graph infinite number of times. And that violates definitional function. And that's what it means. Different inputs produces the same output. That's why we draw the horizontal line test. The horizontal line test basically say, hey, let me see. Okay, how many outputs at this level? Okay. Oh, there are 2 outputs at this level. No, for each input, for different inputs, we must have different output to make it a one-to-one function. Therefore, horizontal line test. Okay, so let's do a little summary before we go further. Let's do a little summary. Okay, so we talk about one-to-one function, right? We also talk about the graph, right? The graph. How do we because one-to-one function, you only consider whether a function is one-to-one if you have decided it is a function, right? Even if it's not even a function, you should not even worry about it's one-to-one or not. So the testing should go like this. If you're given a graph, the first thing you do is a vertical line test. Okay, the first thing you do should be vertical line test. It tests if it is a function. Okay, now, if it is a function, then horizontal line test. Then horizontal line test. And this is to test, this tests if it is a one-to-one function. Okay, so this is the general idea. But anyway, the graph, the line tests, whether it's vertical line test and horizontal line test, they both have to agree with the wording, the definition. They both have to agree with the definition. Okay, so I'm going to make a brief summary about this. Okay, I want you to work with me. I want you to work with me. Okay, so first, you know, I like to use tables, right? I like to use tables. Tentatively, I'm going to just make one more row just in case, right? So first, the first part, we're gonna look at the function, right? Function. For function, we have the definition in words. We have the definition in words, right? We're gonna put the words right there. Oh no. Yeah, the software doesn't, sometimes I have to force it to behave. It has two modes. The software has two modes. It serves my purpose most of the time. One is a math mode, or one is the you know, is the text mode. Okay, sometimes they don't convert the way I want it, so I have to do a little bit something here. Okay, so f of x. All right. Oops, in range. Right, in range. Oops. In range. Okay, the word exactly one is super important. Now we realize, right? Now we realize. So a function is like that. Okay, so let me make the font just a little bit smaller, okay? Now, oops, it doesn't move for me. A rule, okay. No. There, okay. So that rule, right? So then we have a vertical line test. Vertical line test. Okay. If it is a function, only for function, we will conduct the one-to-one function. Okay. And the definition of one-to-one function, and here we go, whenever. Okay, whenever. All right. And then we do horizontal line test. Horizontal line test. Okay, so this is the general. Well, this is just a little summary. I hope that helps, right? And the line test agrees They both have to agree with the definition. Okay? So we have covered function, right? This is a single important definition. And this is actually the theme of this semester. Okay, this is the theme of this semester. This entire semester, everything is about function. So I will cover all the functions all the basic functions you will need for your calculus courses, and variation of them. Okay, and you can see how powerful this definition is. It allows us to cover the contents of an entire semester and beyond. You have maybe 2 more semesters to go to do your calculus classes, or 3 semesters, 4 semesters. In your remaining semesters doing mathematics, okay, you will need this definition. That's how important it is. Do you need a one-to-one function? Yes, you do. Okay, you will need a one-to-one function as well. And our next topics, right? Because we just did the constant function. So let's look at the other function. Okay, let's look at the second one. Is that one-to-one, or is it not, right? So I'm going to bring the second function over here, and we're going to study, is this function one-to-one? Right here. Is this function one-to-one? Is this function one-to-one? Of course, you start to do vertical line tests, horizontal line tests, right? Of course, if you would know the graph, of course you do the horizontal line test, right? To test, we already know it's a function, right? We know it's already a function. It's obvious it passes both vertical line tests and horizontal line tests. But I do want to give you the words. I want to give you the wording that what if you use the definition to speak it? Okay, what if you use a definition to speak it? Okay, so I'm going to give you 2 ways to do this, but you need to learn both ways. Please do. Okay, the graphical way, I know it's easier, but the using words is terribly important for you to be able to use the words to make your case. Okay, this is a part of this course, and this is essential part for your success in your future calculus classes. You have to learn how to use the words. Okay, so I have copied the definition of one-to-one function, right? Because the question is just asking, is a one-to-one function, right? Well, then you just have to use the definition. How do you use the definition? Well, now you have the function right here, right? F of x equals 2x. This function, every output is the same as input. So whenever the input are different, the output are different because that correspondence, right? So the words you use, you will say it is a one-to-one function because this is always true. This is always true, right? Domain is all real numbers, right? X1, X2. You can, of course, you can say X sub 1 and X sub 2 are from domain. Are from domain. That's it. Oh, sorry. Are from the domain. Okay, the domain is here. That's enough. That's enough. But you make sure that the description you made, okay, that description you made is true for this particular function. right? So when x1 and x2 are not the same, well, their output will not be the same. That's the easy case. That's the easy case. And next, right? We're gonna do one. We're gonna do one more, and we wrap up this episode. We're gonna do this one. Is this 1-to-1? Is this 1-to-1? Right? Is this 1-to-1? Right here. I'm sure you're doing vertical line test and horizontal line test at the same time, right? Vertical line test, it passes. Horizontal line test, it passes. It is 1-to-1. But I still, once again, I want to emphasize the importance to be able to use the words. So here I'm going to change the wording a little bit, because for this particular function, it's a cubic function, right? It's a cube function. So it is 1-to-1 because whenever x1 is not the same of x2, I want you to apply the actual definitional function. And that is equals to x sub 1 to the power 3. And this is x sub 2 to the power 3. There are actually different versions you can say this, okay? There are different versions if you can say that. You can actually remove these two. You can say it that way. Basically, you have applied the function, the rule of the function, and make that case, right? Because when these are this is the input, output. The output for x1, the output for x sub 2, right? So whenever the inputs are different, the output are different as well. And you just have to make sure that is true. That is true. Is that true? Yes, it is true. Because you cannot find a counter case whenever, never. Okay. Let's do another one. Is this 1-to-1? How about this one? Is this 1-to-1? Yes, it is, right? But how do you say it? If you use a more specific language here, which is going to be similar, except now it's a cubic root, right? It's a cubic root. It's a cubic root. So cubic root of 3, the domain is all real numbers, right? So these cases, you can study, when you study these, and these are the wording you use, really. And that's sufficient. But you just have to address, we need to address the specific functions. You have to address the specific functions. And then you say, well, could I use the same wording here? You could. It would be better. It would be better if you do it this way. For example, here, you can totally use x1 not equals to x2. Input is not the same as output. Well, input is this, the output x1 is the input, is for input x1. The output x2 is for, input x2. So because the output is always the same as input, right? So you can address it the way you want. Okay, there are variations. The right answer is not unique, but we need to address, we need to cite the definition. Okay, write it down. When you make your case, when you make your statement, you need to cite definition. Okay, you also need to cite the specific functions in our consideration, Okay, so as long as you do these, you make those statements, and you have seen my examples, you're good. Okay, and of course it passes horizontal line test, right? But I still want you to use the words. Using the words will be the best training for you to better prepare you for your calculus classes, okay? Now, we're done with the 4 functions. We have 4 more to go. 4 more to go. Okay, so this guy, is this a one-to-one function? Is this function a one-to-one? Is this one-to-one? There. I hear you. I hear you. Right? It's not. But how do you make your case? If you say, hey, it doesn't pass horizontal line test, no one will say you're wrong. But I want to give you the better training. I want to give you better training to use the words, So if you use the words, of course, the horizontal line test helps, definitely. But you have to be able to speak the language of mathematics. How do you speak the language of mathematics? So here is the ultimate. You go back to the definition. You go back to the definition, okay? You go back to the definition of one-to-one function. And this is what you're going to say. This is what you're going to say, okay? It is not, right? And what is the opposite of it? What is the opposite of it? Okay, so before we say those important words, what is the opposite? What is the general structure for saying it is not a one-to-one function? Well, you have to figure out, this is the definition for it is, right? What is the opposite? What's the opposite? What's the opposite for f of, the outputs are different whenever the inputs are different? Here it is, okay? You would say, the opposite for the output, right? What's the opposite of not equal? The opposite for not equal is equal, right? Okay, but it doesn't have to be whenever. Why it doesn't have to be whenever? Whenever basically says always. We don't need to find to forever, right? Because we say true, it has to be always true. False once, false. So it only needs to be false once. You can say then for some x1 is not equals to x2. Okay, for some, okay? I want you guys to really, really think about this. Because when I was a student, I spent a lot of time math doesn't come easy to me though, okay? Even though sometimes you may look at your math professors and think they look like a wizard. Math is not easy for me. So I want you guys to think about this, okay? Yes, I gave you the answer. Sometimes as you watch the video, you want to pause, think about it, give you time and space to think about it. Okay, you do have that convenience to do so. So I give you the guideline. So I'm gonna finish this question and then we're gonna do another lesson because this is, I don't want to make one lesson too long. Okay. So now as the guideline for this one, because you already know this is not, so we're gonna, how are you gonna make the case? And I have given you the guideline, right? So you just have to pick up those numbers, right? How do you pick up those numbers? Right? And you're going to say, it is not a one-to-one function because, right, you have to apply that, you have to really give me that pair, okay? And here we can utilize, okay, so I'm gonna, let me bring this picture out. Okay, we can utilize that. Oops, I don't need to do that. I need more space. Okay, I can, remember the horizontal line test, right? This horizontal line test tell us what? Okay, so maybe I draw a different one. Okay, draw a different one. Okay, make it easy. You don't have to be so hard on yourself, right? So I'm gonna draw, say 2. Right? This horizontal line I drew here is 2, y equals to 2. Okay, y equals to 2. That's the line I drew there. Okay, so what I'm trying to say is that recall the horizontal line test. Recall the horizontal line test, right? And I drew the horizontal line here already. And what does it mean? What it means? What does it mean? The input this is x squared. I think I should let me do a little different. Okay, just forgive me. I'm going to draw another line because I want to make your calculation. It's just a little bit easier. Okay, so I'm going to make it 4. What am I thinking? I think not only, I think the lecture is, I don't want to make it super long, not only just for you, for your sanity, it's also for my sanity too. Because as I'm tired, I tend to make mistakes where I'm a little slower. Okay, but anyway, so I drew this vertical line, that's 4, but you have so many choices, okay? The one I drew earlier, it could work too, okay? It will work, it would work too. It's just I want to make it easier. And I'm making it easier just not only for you, it's also for me. Okay, so when I draw this vertical line test, I want you to reflect on the definition of one-to-one function that is saying that, you know, what it means for these vertical line tests, right? Well, when you draw these vertical line tests, we touch the curve. We touch the curve at these 2 spots, Okay, and these 2 spots tell us what? These 2 intersections tell us what? It tells us the input, this input is 2 and the output is 4. This input is -2. Forgive me, I'm going to use a different color because they're different values, okay? So this input is -2 and the output is also 4. I hope you hear the details, right? The output, the inputs are different. Input is -2, +2, and the outputs are identical because these 2 red vertical lines are of the same heights, and they are the visual of the output for the two different inputs. So that's the guideline for our making the case, right? For sum. So what is your sum? What's your sum? So here, so I can say for -2 that is not equals to +2, f of -2 is the same as f of 2. In fact, you can also tell the reader, hey, they're equals to 4. They're the same value. If you make a case like this, you'll be perfect. Your teacher will love it. Why? You have cited the definition. You have cited the definition, sorry. Okay, you have cited the definition. Okay, you have cited the definition. So when you say something is or something is not in mathematics, as much as possible, always cite the definition for is or is not. This is the golden rule of study. This is the golden rule of study. I figured that out after years of struggle. So I'm sharing that with you. I'm going to continue to practice, but stay tuned. I'm going to make another lesson on these topics because we still have 3 more functions to go regarding whether they're one-to-one. So I encourage you to before you watch the next recording, try your own, okay? Because I have given you the tools to such a study. Try your own and stay tuned. Thank you for watching.